So now we are going to discuss about the nonlinear characteristics component which is going to be used here as a modulator. Okay. So before entering to the modulator working principle, first we will discuss about the nonlinear characteristics. Okay. Nonlinear characteristics. So nonlinear characteristics means, as I have drawn in figure, the characteristics between current and potential must be nonlinear in nature. So nonlinear in nature means either we can go for diode, either we can go for transistor, either we can go for MOSFET, either we can go for our BJT bipolar junction transistor or field effect transistor. Any of these nonlinear devices or semiconductor devices we can use act as a modulator. Means less amount of potential is provided so that maximum current can be drawn. After that, need potential. Okay. Using this graph, a relation I am deriving, that is A plus BV. Okay. Now A plus BV means I is related with respect to V. Since it is a linear, if I will say linear means I can say it is called I is equals to BV. Like B is called as our resistive value. But if it is non-linear, it will add one more component to it so that with a minimum amount of potential, maximum current can be drawn. Now let us consider the constant A is 1.8 and V is 2 and our input potential is 1.5. Let us consider the input potential is 1.5 volt. So for 1.5 volt, what the output current we should get? The output current I is equals to 1.8 2 into 1.5. So it is 1.8 plus 3. So that means 4.8 ampere current it's generated with the help of this sort of resistor. So in this case what happens? The nonlinear characteristics with small amount of potential, the maximum current we are drawing. But if it is a linear characteristic, let us consider I is equals to BV, B is 2, V is 1.5. So what will be the current we will draw? The current will be maximum 3 ampere we can generate. But if it is a nonlinear characteristic, the current can be generated by 4.8 ampere. So this is the small relation through which we can correlate that with small potential the maximum current can be drawn and that current can be converted into the magnetic field while transmission of electromagnetic waves. So for this we will form certain relation through which the characteristics of nonlinear element can be analyzed. So first the mathematical analysis will be mathematical analysis. Okay. So for this, either we can choose a diode, either we can choose the transistor, either we can choose the field effect transistor, that is FE. Okay. So these are the certain nonlinear characteristics. This is emitter, this is base, and this is collector. And this is gate, this is drain, and this is source. So these are the certain relations or certain nonlinear devices which can be used for modulators. Because here two input we require. In this diode, before sending the total amount, let us consider Vs I am providing. In this Vs, already two amount of potential if I will add, then Vs if I will provide, only the rectified outputs will be generated. That means if there is only one diode, that means output will be only one output will be available or only the positive half cycle of a particular signal is available. If there are two diodes are available, that means two waveform will be generated, one with respect to positive, one with respect to the negative, and that will be the DC components we are generating. Okay. So for this sort of devices, I can write the current equation I is equals to A plus BV plus CV square plus D VQ dot dot. That means the potential, as we are giving the less potential, but current one is maximum. So for consideration, need not to consider, for consideration purpose, I is equals to A plus BB plus CV square, neglecting the higher component. Okay. If we are neglecting this higher component, we are using this sort of potential. Now what is this V? V is the total potential available to our this non-linear element through which the current will be generated. For example, if I am using a diode, okay, this diode in which the supply potential is Vs. Now let us consider the modulator. This is my modulator in which carrier is provided, in which message component is provided, and I am generating an AM signal. So that means two potentials were provided to a device through which the AM signal is generated with some sort of change of characteristics of carrier with respect to this message component. So let us consider this mixer is replaced by a diode. So how many potential we are providing? Two potential. One is message, one is carrier. So V1 plus V2. So supply potential is this. Similarly, here I can identify the diode current, and with the help of that Shockley diode equation, we had the relation that ID is equals to I naught whole into 1 minus e to the power some factor, and that equation is called as our non-linear relations. Okay. Now depend upon this drain current, means diode current, this potential is related with respect to these equations. Now here this V is equals to V1 plus V2. Small v is equals to small v1 plus small v2. Now what is small v1? Small v1 is equals to capital V1 cos omega 1t, or you can write in terms of sine also. Any relation we can write. So it is V1 sine omega 1t, and small v2 is equals to capital V2 sine omega 2t. Done. So these are the two potentials or continuous signal which is provided to the nonlinear element. Now once this nonlinear element filled with some sort of source, the output what we will get with respect to current we will see. So I is equals to A plus B. In place of V, I will write V1 sine omega 1t plus V2 sine omega 2t plus C into V1 sine omega 1t plus V2 sine omega 2t whole square. Now we need to expand this relation to find out the DC components and other spectral components. So A, first one is B V1 sine omega 1t plus B V2 sine omega 2t. Now it is in A plus B whole square term. Expand it, we will get V1 square sine square omega 1t plus V2 square sine square omega 2t plus twice of V1 V2 sine omega 1t into sine omega 2t. So this is the relations what we have derived from our nonlinear characteristics. Now these nonlinear characteristics will help us to identify the presence of carrier, presence of modulating signal, presence of sideband, presence of harmonic component. If I will expand this, everything it will come. Now since it is sine square theta, I can write 1 minus cos 2 theta divided by 2. Like this I can write. Or if I want to write cos square theta, I will write 1 plus cos 2 theta divided by 2. So since we are using the sine terms, I will go for 1 minus cos 2 theta divided by 2. If I am using cos, then it will be 1 plus cos 2 theta divided by 2. So these are the small relation which we are going to substitute in above equations. Now it is A B V1 sin omega 1 t plus B V2 sin omega 2 t plus C into V1 square divided by 2 minus C into V1 square divided by 2 cos 2 omega 1 t. Okay, plus C into V2 square divided by 2 plus, sorry, it is minus V2 square divided by 2 cos 2 omega 2t, and this expansion is in terms of sin A sin B. So here I will write C V1 V2 cos of omega 1 minus omega 2t, and another component is, since it is minus C V1 V2 cos of omega 1 plus omega 2t. Done. So these are the spectral component which is available in this particular equation. So first DC component, how many DC components are there? A is a DC component, C by V2 is a DC component, C V2 square by 2 is a DC component. Now what are the fundamental frequencies are available? One is sin omega 1, one is sin omega 2. So these are the fundamental frequencies. And what are the harmonic components are available? Harmonic component means the second terms like cos 2 omega 1t and cos 2 omega 2t. So these are the two harmonic component which is higher than these sine components omega 1 and omega 2. And these are the two spectrum, or you can consider these two are the sideband. One is omega 1 minus omega 2, one is omega 1 plus omega 2. So these are the fundamental components which is available in our output current, and this output current I will say it is called as AM current. Okay. So here one by one we will write. First, what are the DC component is available? DC component is A plus C V1 square by 2, and second one is C V2 square by 2. So this is the DC component. What are the fundamental frequencies are available? Fundamental frequencies or fundamental components. Fundamental components are B V1 sin omega 1t plus B V2 sin omega 2t. So this is my fundamental component. Now what are the harmonic components? Harmonic component is higher frequency component. So what are the higher frequency component? Higher frequency component is minus C1 V1 square divided by 2 cos 2 omega 1t. Okay. Next, minus C1, or it is C V2 square divided by 2 cos 2 omega 2t. So this is the higher frequency component with a negative amplitude. This is the harmonic component, fundamental component, DC component, and what are the sidebands are available? Sidebands are, it is C, V1, V2, cos of omega 1 minus omega 2t minus cos of omega 1 plus omega 2t. Okay, since we have considered sine term, we are getting in terms of cos of A minus cos of B. If it is in terms of cos, here we will get in terms of plus. Okay, that is the small difference. So these are the fundamental component available in my AM signal, or I will say it is called I is the current, and this current is called my AM current, in which the modulating signal is available, carrier signal is available, spectral components are available, harmonic components are also available. Now in order to transmit the AM signal consists of carrier and two sideband, but these are the other components are available in my signal. So what I will do, I will pass this whole signal through a certain filter who will only consider the carrier and consider the sideband, and rest of the component, whether it is a DC component, whether it is a fundamental component, whether it is a harmonic component, will be eliminated or will be suppressed, and only the AM component is going to be transmitted. So after this is the output of a nonlinear device. This output of a nonlinear device must be filtered. Output of that filter, we can say it is called as AM signal. So this is the certain relation which we will again elaborate with respect to modulating signal and carrier signal. What are the fundamental frequencies are available, what are the harmonic components are available, and how it will be detuned with respect to other components, and AM signal is going to be available. So this is the fundamental terms is available at the output of a nonlinear element. Okay. So now we will see the generation of AM signal using a nonlinear device and that modulator is called as square log modulator, or it is called as diode modulator. So the first modulator is square law diode modulator, because in this we are going to use the diode and the characteristics with respect to potential and current in terms of square. So here what happens, we are using a diode as a modulator. Here I am providing a carrier signal, that is small DC. Here I am providing the message component small boolean, and I am using a DC potential to fix the operating point, and I am using a filter or tuned circuit, that is LC component L, and this is C. So whatever the output we will get here, V out, is called as our AM signal. This is the square law diode modulator. So this is the diode nonlinear element. Here the Vs is provided and diode current ID we have to identify, and that ID need to be filtered out so that AM signal can be generated. So step by step we will see. And what is the use of this DC potential? It will fix the operating point while we are considering the VI characteristics of a diode. Okay. So first, the diode characteristics A plus BV plus CD square. Now what is this V? V is nothing but the supplied potential, Vs. Now what is this Vs? Vs is Vc plus Vm, means carrier plus modulating signal. This is my carrier and this is my modulating signal. Okay. Now next, you need to substitute this value here. But first of all, what is Vc? Let's see. Vc is equals to capital Vc cos omega Ct, and what is small vm? Small vm is capital Vm cos omega m. Here I have considered both are cos. In previous I have used sin. Anything you can consider. Consider this one a sine term, or this is also sine term, or this is cos, or this is cos. Now you need to substitute this value in this equation and need to expand it. Okay. So output current A plus B. What is Vs? Vs is equals to Vc cos omega Ct plus Vm sin cos omega mt. Then plus C into Vc cos omega Ct plus Vm cos omega mt whole square. Okay. Now you need to expand this relation. As we have expanded for that nonlinear characteristic, same thing we have to expand here. First is A, B into Vc cos omega Ct plus B into Vm cos omega mt plus, this is square term, I am expanding it, so it is Vc square divided by 2 plus Vc square divided by 2 cos 2 omega Ct for this square term plus C into Vm square divided by 2 plus C into Vm square divided by 2 cos 2 omega mt plus, this is twice term, so C into Vc into Vm cos of omega C minus omega mt plus C into Vc into Vm cos of omega C plus omega mt. So these are the expansion of this above component. Okay. So now what are the DC component? A is the DC component, C into V square by 2 is a DC component, C into Vm square by 2 is a DC component. So DC component available is A plus C Vc square by 2 plus C Vm square by 2. So this is my DC component. What are the fundamental frequencies are available? Fundamental frequencies are available as B Vc cos omega Ct plus B Vm cos omega mt. So this is the fundamental frequency. These are the fundamental frequency. And what are the harmonic components are available? Harmonic components are this one. C Vc square by 2 cos 2 omega Ct plus C Vm square by 2 cos 2 So this is my harmonic component. And what are the sideband components we have? The sideband components are C, VC, Vm cos of omega C minus omega m of t plus VC, Vm cos of omega C plus omega m. So these are the parts available in the output of this signal, output of this diode. This is ID. Okay. Now this output current need to be filtered to generate an AM signal. Now AM signal, what it indicates? AM consists of carrier plus sideband. So carrier and sideband means in this equation you can see DC component is available, carrier component is available, message component is available, then harmonic components are available as well as sideband components are available. In order to generate this carrier and sideband, other functions or other component need to be suppressed. In order to suppress those components, we are using a LC tuned circuit. This LC tuned circuit will generate a resonating frequency. We had a relation. This is 2 pi root over of LC. And this resonating frequency is synchronized with the carrier frequency. Means it is centered to the carrier frequency and to the sideband frequency. Okay. This resonating frequency of a LC tuned circuit, or I will write FR, is called as resonating frequency of this LC. If you vary this C, your frequency is going to change. And this particular resonating frequency is act as a central frequency for your carrier and the sideband. So it will concentrate only to the carrier and the sideband component. Rest of the component like DC component, fundamental component available with modulating signal, as well as what are the higher components are available, that also it will suppress. So output of this particular LC tuned circuit, the working principle of tuned circuit is that it will generate a resonating frequency which is centered to the carrier frequency as well as to the sideband, and rest of the component will be suppressed. Now if I am using this LC tuned circuit, that means output of this tuned circuit, what I will get. So whatever we have derived, it is all about the output of diode current, that is called ID. Now we will see what is the output current available with respect to the tuned circuit. This is LC. Now this LC is FR is matched to FC as well as to the sidebands. So output current which is available here, output current. Okay. Now this output current must consist of carrier and must consist of sideband. Modulating signal, higher frequency component, or it will be suppressed because this resonating frequency is matched to the carrier frequency. That means harmonic components automatically it will suppress. Harmonic means maximum frequency. It is only centered to the carrier frequency and the sidebands. Okay. So output components are first DC component, it will suppress. All the DC component means A plus C into V1 square by 2 plus C into V2 square by 2. That will be suppressed. We will get B into VC cos omega C. So this is the first component we are getting. Then modulating signal, since it is less than carrier frequency, it is automatically it will suppress. And it will only identify the sideband. So what is the sideband? C into VC into Vm cos of omega C minus omega m of t plus C into into Vm cos of omega c plus omega m of t. So this is the output of this tuned circuit. Output of this tuned circuit means that is called AM signal, in which carrier component is available, sideband signals are available. So my tuned circuit will only tune to the carrier frequency as well as to its sideband. So carrier frequency is this and sideband components are this. Okay. Now what I need to represent this all equation in terms of AM equation. Then only I can say I have got the AM current. So how to write this one? So first I output is equals to VC cos omega Ct. This I can again regain back to twice of VC Vm C. Here I will write cos of omega Ct into cos of omega mt. Like this I can write, because this is cos A cos B. Add these two components, multiply 2 to it, and C is a constant factor. Okay. Now in this, if I will take Vc cos omega Ct as common, okay. So Vc taken as common as well as cos omega Ct, I will get 1 plus 2 C into Vm divided by V cos omega mt whole into cos omega Ct. Done? So this equation is quite similar to our AM equation. Okay. So here what I will write, this you can consider as your modulation index. Modulation index is equals to twice of small c Vm divided by small v. Okay. So this is your modulation index. So if I am replacing this whole component as Ma into cos omega mt into cos omega Ct, then this become the amplitude of a carrier. This is the modulation index of a AM signal. This is our modulating signal, and this is our carrier component. Now the same equation I will write in terms of AM so that you can correlate. So whatever the outputs we are getting, it is the AM current, and AM current is represented in terms of potential. So S suffix AM, the general equation is A plus M of t whole into cos omega Ct. AC take common 1 plus M of t divided by AC whole into cos omega Ct. Now in place of M of t, substitute 1 plus Vm cos omega mt divided by AC cos omega Ct. Now this I can replace as AC 1 plus Ma cos omega mt into cos omega Ct. So this is my AM signal as we have represented as a general equation. Okay. Now this equation I naught is the output current. This equation and this equation both are, it is correlated. So that means you can consider this, if I will compare these values, AC is equals to B into VC, MA is equals to twice C into Vm divided by V. Okay, AC is equals to V into Vc, MA is equals to 2C into Vm by V, and cos omega mt, cos omega Ct. I have derived the output current of a tuned circuit is called as an AM signal. And what is the working principle of the tuned circuit? That the working principle of the tuned circuit is the tuned circuit will generate a resonating frequency. Since it is a LC tuned circuit, that resonating frequency is matching to my carrier as well as to the sideband, suppressing the DC component, suppressing the harmonic component, and suppressing the other modulating signal. So output is available with respect to carrier and to sidebands. Okay. So this is called as our generation of AM signal using square law diode modulator. Why it is square? Because here potential is square, non-linear. So this whole modulation technique is called as our non-linear modulation. Okay. So for today we will wind up to this. Next session we will continue with demodulation technique for this square law demodulator. Okay. Thank you. सेव हो रहा है ऐसा